So today we're going to be looking at the quadratic formula again. Only today we're going to get complex number solutions instead of real number solutions. So for your essential question, I want you to answer in a complete sentence, what does it mean when a quadratic equation has two imaginary solutions? But before we get to our guided practice problems today, I want to go back to this picture that I've showed you guys a few times and remind you of the relationship between the graphs and when we solve for our solutions analytically using the quadratic formula or factoring or whatever it might be. So remember, in the case where you have two x-intercepts, that is two real number solutions, two real solutions here. In the case where your vertex is on the x-axis, where your vertex and your x-intercept are the same point, this is where we will have one real solution. And in the case where our graph does not intersect the x-axis, this is where we will have two imaginary solutions when we solve our work analytically. So again, when we solve and we get those imaginary number solutions, that means our graph does not intersect the x-axis. So let's take a look at our guided practice problems. Okay, so we are going to solve using the quadratic formula. We need to write our answers in simplest radical form, and then when we're done, write the number and type of solutions for each question, for each equation. So just like with 5-3, we're using the quadratic formula here. First step is to make sure the equation is equal to 0. That's already done for us here. From there, we want to go ahead and identify the a, b, and c values. So from this equation, we're going to identify a is equal to 3. This is in standard form. B is equal to -8. And c is equal to +10. Make sure that you are listing those negatives, and when you substitute into the quadratic formula, make sure that you are using parentheses. So from here, we're going to plug into the quadratic formula, and again, make sure we're using parentheses. So we have x is equal to -b, so that's going to be a -8, plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Make sure, again, you use those parentheses. From here, we want to go ahead and simplify. So a -8 becomes a +8, plus or minus the square root. This is a -8 squared, which is -8 times -8. And again, that's where a lot of mistakes happen, so be really careful with that. And that's going to give us a +64. 4 times 3 is negative 4 times 3, excuse me, is -12 times a +10 is -120 divided by 2 times 3, which gives us 6. From there, we want to simplify further. So inside the radical, we have 64 minus 120, which is going to give us a -56, all divided by 6. We want to go ahead and simplify that radical. So we have the square root of -56 that we need to separate into its real number and imaginary number part. So we have the square root of -1 and the square root of 56. We know that the square root of -1 is equal to I, and we're going to cake that 56. So that's 2 and 28, 2 and 14, 2 and 7, and 7 and 1. Here we have a pair of 2's, a leftover 2 and a leftover 7, so that's going to come back together as 2 radical 14. And that I is going to appear between the 2 and the 14 when we put it back together. So this becomes 8 plus or minus 2i radical 14 divided by 6. At this point, again, we want to simplify by dividing if possible. But remember, we can't just cross out single numbers, so we want to factor out the GCF from the numerator. So we're looking here at the 8 and the coefficient on the radical, which is the 2. So 8 and 2 are both divisible by 2. So I'm going to factor that 2 out of the numerator, and that leaves us with 4 plus or minus 1i, which we don't write the 1, so just I rad 14 divided by 6. And now we can go ahead and simplify that 2 and that 6. They're both divisible by 2. And that's going to leave us with 4 plus or minus I rad 14 over 3. Now again, I want you guys writing these as two separate numbers so that we keep in mind that that plus or minus gives us those two separate numbers. So we're going to write this as 4 plus I radical 14 divided by 3, and x equals 4 minus I radical 14 divided by 3. And this is two imaginary solutions. All right, let's take a look at one more just to be sure we've got this. All right, so again, we're using the quadratic formula. First step, still make sure our equation is equal to 0. So we're going to go ahead and move the 9 to the left-hand side. Now that 9 is positive, so in order for us to move it over, we have to subtract it. So we're going to subtract 9 on both sides. Now remember, when you do that, you can only combine it with other constants, which are other numbers that don't contain a variable, which we have none of on the left-hand side. So when we rewrite this, it's going to just be its own term. So we have negative 2x squared plus 5x minus 9 is equal to 0. From here, we want to identify the a, b, and c. So a is equal to negative 2, b is equal to 5, and c is equal to negative 9. We're now going to take those and plug them into the quadratic formula and use our parentheses. So x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times negative 2 times negative 9, all divided by 2 times negative 2. Be careful with that negative. Again, this is where people will also make mistakes, so you want to be really careful with those negatives. From here, we want to simplify. So it's going to be negative 5 plus or minus the square root of 5 squared, which is 25. Negative 4 times negative 2 is a negative 8. I'm sorry, is a positive 8. Positive 8 times negative 9 is a negative 72. Divided by 2 times negative 2, which is negative 4. So when we simplify inside of that radical, that's going to give us negative 5 plus or minus the square root of negative 47 divided by negative 4. And we want to simplify this radical here. So the square root of negative 47 is going to be the square root of negative 1 times the square root of 47. We know that the square root of negative 1 is I, and 47 is actually a prime number, so we are not able to simplify that at all. So when we put this back together, that's going to be negative 5 plus or minus I radical 47 divided by negative 4. So here we get x equals negative 5 plus I radical 47 divided by negative 4, and x equals negative 5 minus I radical 47 divided by negative 4. Now notice that for both of these questions, the numerator and the denominator both begin with a negative. We don't want to leave all of those negatives happening in this case. So what we want to do here is, again, go back to that numerator, and we want to divide out the negative as a GCF. Now, again, this is only the case when your denominator and your numerator both have that negative out in front. So what we're going to do is we're going to divide out that negative in the numerator. That's going to make this 5 become positive, and the I rad 47 become the opposite, which would be negative. Same thing over here. We divide out that negative, that 5 becomes positive, and the I rad 47 will also become positive. So what that now allows us to do is to simplify this negative, giving us a final answer of 5 minus I radical 47 over 4 and 5 plus I radical 47 over 4. Now make sure you make a note that, again, this is only the case when that numerator and the denominator both have that negative out in front. This is solving for complex solutions. Don't forget to answer your essential question.